All right, TJ, this is section 6.2. We are diving right in. Section 6.1, we actually went through a lot of the stuff that's in 6.2. So you're going to know all of this stuff already. This is just more practice, okay? Because we got to get really good at doing this stuff, all right? They give you the formula. Again, you should have this memorized, hopefully. We use different symbols than they did, okay? Get this stuck in your brain. To find a z-score, you take x, which is our value, if you want to label these. This is our value, or the value that we're looking at, okay? Minus, instead of calling it mu, we called it x bar. Both of those things stand for the mean. And then divided by, they call it sigma. We're going to call it S for standard deviation. But sigma means the same thing as standard deviation, okay? So our value minus the mean divided by the standard deviation, that's how you find the z-score. Get that in your brain. That should be like memorized. Can you memorize that? That's not terribly hard, right? No. Okay, get that stuck in your brain. That's what those values mean, okay? All right, we're going to use that a lot in this section. We've already used it already in a couple of the problems that we did in 6.1, but we're going to use that a lot today, okay? All right, ready? We're waiting on MJ because he's slow.
Oh, I'm ready.
Okay, he's ready. All right, example 1. What proportion of men are taller than 72 inches? Here we go. Heights of men are normally distributed. Write everything down so you don't have to reread. With a mean of 68.6. What does that mean? What is that? X bar. I'm going to write it down. 68.6. That's my middle number, right? If I put it in the middle, 68.6. What did you say, Maddie? Okay. 68.6 is the middle number. It reflects a z-score of 0, right? If you are on average, you have a z-score of 0. Okay? And a standard deviation, we'll call that guy S of 2.8. If you want to call it sigma, I don't care. S is 2.8. So you're adding 2.8, you're subtracting 2.8, etc., right? I'm not going to fill out the bell curve. Can I get away with doing that? Or should we? Should we?
No.
No.
Well, yeah.
Sure. Okay, let's do it. 1, 2, 3, -1. I was just going to fill these in and not fill in the other ones. Okay, so somebody add 2.8, 2.8, 2.8 for me.
71.4, 74.2.
Okay, 71.4, 74.2, and 77. Okay, perfect. Subtract. Minus, minus, minus.
65.8.
65.8. 63.
60.2.
And 60.2. Okay. Okay. I'll pause for a moment. Caleb, we're on example 1 of the 6.2 notes.
All right.
Okay. All right. It says find the percentage. We're looking for percent. Okay, let's find our thought process here. Percent. That's what we ultimately want to get to. Find the percent that is taller than 72 inches, okay? All right, to get a percent, we have to look it up on here. But in order to look it up on here, what do we have to know first?
Z-score.
The z-score, right? Do we have a way of calculating the z-score for 72? Okay, z is equal to, we know x and we know s. We know x bar and we know s. What is x that we're trying to find?
Our number.
72, that's our number that they're giving us, right? Okay, so now we just use our z formula. 72 minus, hold on, just wait a second. 72 minus 68.6 divided by 2.8. Okay, before you calculate that, Kelsey's got this number for us. If we look at the chart, where is 72 going to be located? Right after 1. It's going to be like 1 point something, right? If we calculate the formula exactly, what's the z-score?
1.21.
1.21. Always go to 2 decimal places because that's what your table goes to, right? 1.21. Okay, so we're marking off here and we're trying to look up the percentage now. Well, the table is the only thing that gives me percentage. Are we on the positive side or on the negative side? Positive side, and we're looking up 1.21. Everybody look it up so you can find it. 1.21. Find it. I'll give you a second. 1.21. Lily's got it for us. 1.21. Look it up. Okay, 0.88 what? 0.8869. That's 88.69% if you move the decimal. But that is not the correct answer.
Thanks.
She's right.
You have to, so 88.69.
Okay, what? 88.69, right? If we convert it to a percent, right? If you want to do that, you can.
It's still wrong.
But it's still wrong.
It's
What's wrong with it?
11.31.
It's what?
On the wrong side. The right answer.
You have to subtract it.
Why do you have to subtract it?
Because it's
Because
on the
it's
wrong side.
Because we're looking for
We need the tiny-
who is what?
Taller.
Taller.
Taller. We're looking for this chunk right here. And the table always reads to the left. So this guy is 0.8869, right? Are we getting the hang of this? This is getting better, maybe? So here we have to subtract, right? So 100 minus that is 11.31%. There we go. That's the percent of people that are going to be taller than 72 inches. Anybody in here in that range? Are you taller than 72 inches? So that's 72 inches would be 6 foot exactly. Yeah?
Yeah.
So you're in the tallest 11%, according to this average and standard deviation. According to our average of 5'8", right? 5'8" is average. You are considered in the top 11% if you are above 6 foot, right? According to this data. Okay, make sense? Good. Are we happy with that? Do we understand why we have to subtract? We're looking for taller than 72. Okay, let's go down here. Air Force height requirements. I like this example. The U.S. Air Force, they decline people. Did you know this? Like if you're going into the Army, like, or in, you know, certain things, you have to be certain, like, dimensions. Like if you're too short or too tall, they will not accept you, which I think is kind of crazy, but this is why. Here you go. The U.S. Air Force, these are people flying the planes, right? Requires that a pilot have a height that is between 64 and 77. Okay, those are going to be our values. So those are our X's, but we have 2 of them, right? We've done it before. We have 2 markings, right? We're going to figure those out, okay? Those are our X's. And then it says heights of women are more normally distributed with a mean of 63. That's 5'3", or almost 5'4", and a standard deviation of 2.9. So let's fill this out. Let's say X bar, 63.7. Standard deviation is 2.9. Why would they make a requirement, like a lower height requirement and an upper height requirement? Why would they do that?
The seats.
The seats in the plane. Like they're not gonna like redesign a plane for you because you're 7 foot tall, right? Or they're not gonna redesign a plane for you so you can fly it when you're 4'9", whatever. Sorry, Indy. So you have to be certain height requirements, otherwise the pedals aren't gonna fit you and you know, whatever. So that's how that works. Okay, I'm gonna put 2 X's in here. We have 2 different X's. They are first 64 and they are 77. Okay? Now, what happens if they would have given you like 5'4"? What if they give you like 5'4" for your calculations? Convert it to inches first because you can't do calculation. I mean, it's easier to do calculations in inches rather than feet in inches, okay? So do this first. Let's go ahead and label our stuff. 63.7 is here. That's at 0. Then we have 1, 2, 3, -1, -2, -3. Should we label this or not? Yeah? Okay.
66.6.
66.6.
69.5.
Okay.
72.4.
72.4. Okay.
Going the other way.
You are awesome, Kelsey. Look at you. 60 what?
0.8.
0.8.
57.9.
Okay.
And 55.
And 55. Yeah. Say thank you. Say thank you, Kelsey.
Thank you, Kelsey.
Mm-hmm. There you go. All right, so let's figure out where our values are. Okay, we have 64 as a value. Where is he going to live?
A little to the right.
A little to the right of 0. Okay, and 77? Wait a second. Wait a second.
You messed it up.
Wait a second.
It's 77 is 4.586.
77? Are you kidding me? Did they give me the right numbers here?
I calculated it.
That mean seems wrong, but
No, if this is right, and there's a reason why they did this, and I'll show you. Women, get ready to be mad.
Because we don't get to 77 inches.
Get ready to be mad. All right, here you go. If the average is 63.7, they're saying the minimum height requirement is 64. So the average female doesn't even fit this requirement. Why? Because they've designed these planes for men to fly them. Isn't that ridiculous?
No. And we're not in the draft.
Anyway, so that's why we're skewed to the right a little bit. Anyway, so the average female doesn't even fit this range. All right, we're trying to find the percentage that's in between these. This is what we're trying to find, the percent that's in between those. Okay, so what do we need to find first? We're doing percent, but before we get to percent, we have to find z-score, right? And we have 2 of them, okay? So let's calculate z-score for both of those. The z, we're going to do first of the 64.
No, you should do the 77.
It's fine. I'm going to do both. We're going to do both of them at the same time. 77 minus 63.7 over 2.9. What?
The first one's 0.103, the second one's 4.56.
We'll go 0.10 because we have to do 2 decimal places. Okay, so Kelsey's calculated these. She said 0.10 just to the right of 0. That's that guy. And then what's the z-score for 77?
4.59.
What the heck? 4.59? Wow, that's a z-score. Do you remember me telling you that z-score normally is between -3 and 3? But this one is so high because they're basically, the numbers, the 64 and the 77 are based off of probably the men's average height, right? That's probably what they're basing off of, but we're looking at women here. Okay, so. Okay, 0.10 and 4.59. All right, go to this table because we're going to run into an issue. We're on the positive table. Look up 0.10 as a z-score. What percentage? 0.5040. And that is from here on to the left. 0.5040. Okay, everybody try to look up 4.59.
Oh, wait, go back. You can.
No, that's
Do you see it?
Right there.
Everything that's above
Mrs.
3.5. What?
The first one's wrong.
Oh, the first one's wrong. What is it?
Yeah,
It should be
0.5398.
Oh, 0.5398. 0.5398. She probably said it right and then I wrote it wrong. 0.5398 is 0.10 on the positive.
It's 0.10, not 0.01.
Oh, wait.
Oh, yeah. 0.10.
Wait,
Yeah.
pause.
Okay, pause.
Okay, so go back to the 0.10 and 4. Okay, that's.
Okay, 0.10 is not 0.01. 0.10 is down, like second line, first one over. It's 0.10. 5398. 53.98%. Okay? Then if we look at 4.59, we don't even have a 4.59. Anything bigger than 3.5 is 0.9999. 0.9999. So 99.99% are going to be lower than that person, right? Which makes sense. Like 99.99% of women should be below 7 foot or 6 foot 7 inches tall, right? You'll sometimes have like a person over that, right? But not very often. Okay? 0.9999. So if we want to find the percentage in between those two, we subtract them. So our percentage,
46.
Indy, you're right. We should have done it the other way around. Because the bigger, yeah. Anyway, 0.9999 minus 0.539. I'll just listen to you from now on.
We were doing it right this time.
4.49.
What?
Never mind, don't listen to me.
Point?
46.
46 is 0.0%.
0.46 what?
1%.
01? Okay, so 46.01. What does this mean?
That is the range percentage.
Only
46%.
46% of women who want to be in the Air Force are accepted based on their height requirements. Just based on height. And then after that, we might still kick them out because of their, I don't know, like their eyes. They test your eyes, and if your eyes aren't good, then they kick you out then too. So 46%, only 46% of women make the height range to begin with.
I think I have.
Then they lower you down from there,
In
right?
fact, I can't do
Okay?
it. Wait, I have a question. So, what was the other way that we could have done it? Like,
What?
were you talking about? Like, I was right.
Oh, you said let's put the 77 on top, right?
Yeah.
And I said we should have put the 77 on top because that was the 99. Anyway, whatever,
Yeah.
you're fine. So it wasn't a different way. It was just like putting these, writing these in a
Yeah,
different
you
order.
gotta do the
Whatever.
second, the biggest
Yeah.
one, and then the-
I know. You're right. You're right. Okay, go to example 3. When designing equipment, one common criterion is to use a design that accommodates 95% of the population. In example 2, we saw that only 46% of women satisfy the height requirements. We did that right. Ha! What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? So they're saying
I wanna be a pilot.
if here is 0 and 95% is the cutoff mark, where is the division line at? If we're going to allow the shortest 95% of women, where are we going to divide?
Yeah, right.
On the right,
Oh.
right?
Oh,
That
yeah.
means 95% are located here and 5% are this way. Yeah? 95% to the left, 5% to the right. Okay? We're trying to find what this value would be. Okay? We still have the same X bar and we still have the same standard deviation. They give it to us again. 63.7 and 2.9. We're trying to find what that height requirement needs to be. Okay? This is going to be a new one, but we've done this before. Okay? We did this on the cookie sheet or on your height sheet, I think. Maybe. Okay? So, we need to find a z-score. We're ultimately trying to get to the X value, right? They're giving us the percentage. So we're going to go from percent to what? We have to go from the percentage value to the z-score, yeah. And then we go from the z-score to finding what that height represents. So we have to do those steps. That's kind of like our step process. We start with the percentage, which is 95%. We move to the z-score, and then we move to the X values. So we're going to look up in the table backwards, right? This is backwards in the table, so if you need to write that down. Okay? All right. As 4 decimal places, you're looking at 0.9500, right? We know that, okay? And this is the star, right? If you look up on the positive chart, there's a star there because it's exactly in between.
Oh my goodness.
Okay?
1.65.
1.645. Woo!
Yes.
That's the one.
That one.
So the z value is 1.645. Yeah? Okay? That's a z-score that corresponds to that percent value. You're looking at backwards in the table. Okay? 1.645. We don't know the X value. That's what we're trying to find. What height corresponds to a z-score of that? So, this is the formula, right? X minus X bar divided by the standard deviation. We're going to work backwards, right? We've totally done this stuff before, right? I taught you this in section 6.1, even though I wasn't supposed to, but now you know, right? Yeah, so you know what you're doing already.
How would they figure out all the worksheets?
What do you mean?
Like all the worksheets have those problems.
Because every year I teach it that way.
Why?
Did you make the
Yeah.
Oh, it must have been.
So I gave you 6.2 problems in 6.1, so it's like doing 2 lessons of kind of the same, so you have extra practice on everything, right? Because this stuff is important. All right,
Still gonna mess
so
up on it.
how do you find X now?
multiply over? And then
Multiply the 2.9?
Yeah.
Okay, multiply by 2.9. After you multiply that by 2.9, keep that number in your calculator because then you're going to add the 63.7, right?
Exactly.
Yes, so X is, how tall do we have to be?
68.47.
68.47? What? 68.47 what? Percent?
No.
Inches. That's a cutoff mark for inches, right? So if we choose to, rather than going all the way up to 77 inches, if we cut off the top, like the tallest 5% of women, and we're saying, you guys are knocked out, now the upper limit is 68.47. Does that make sense? You see how that works? Yeah. Anybody have questions on that? MJ's looking like, what the heck did you just do?
Wait, so we times 1.65 to 8.9?
Yes, and then add the 63.7 over. Right. You're just unwinding the the right side. Yeah? Good? Happy with that?
Yeah.
Okay, let's see what. Oh, this is it. All right. Should we get through this example and then I'll give you a work day tomorrow because Ellie's going to be gone and then I don't have to record for her one problem, right? Should we do that? Okay, I'll give you a day to work tomorrow. So, example 4, significantly high versus significantly low. We know 2 standard deviations, right? Is significantly high, significantly low. Use the preceding criteria to identify pulse rates of women. What are we talking about here? Oh, they give me the data. Pulse rates of women that are considered to be significantly high or significantly low. Assume that women have normally distributed pulse rates with a mean, write that down, of 74.0 and a standard deviation of 12.5. Okay? All right, so we know that it's 2 and 2, right? The z-score is 2. So 2 above and 2 below. right? That's considered to be significantly high and significantly low. 74 is here.
86.5.
2 above, 2 below. What
86.5.
is the next one? Yep, 86.5.
99.
We don't even have to do anything.
111.5.
Okay,
61.5 on the other side.
okay,
49.
okay,
And 36.5.
and 36.5. Okay, so -2 to +2. Those are our cutoff marks for what's considered to be significantly low and significantly high. We don't even have to do any calculations as long as we fill the chart out. Which, thank you, Kelsey, for doing that again for us.
We need to give her
Right?
some bonus points.
I know. So, what's considered to be a significantly low pulse rate?
Or 49 or lower. Less than 49.
Yeah, significantly low. That is X's that are less than 49. Is it less than or equal to or just less than?
Less than.
Just less than. If you're on 49 exactly, you're not technically significantly low yet, right? Okay? Significantly high is anybody that is above 99. That's me on some days. My pulse rate's a little high.
Is that all we have to find?
Are you significantly low yet? No?
Not right now.
Not right now?
My resting heart rate problem is.
Yeah. You're low. Everybody else, I think when we did it before, you guys were all in like the 70s or 60s, something like that. So you're normal. We're weird. You know, whatever. Okay? All right, so I gave you that's the notes. That's the notes for everything. You guys should be able to do these bell curvy things. Okay? I'll give you time in class to work tomorrow. Tomorrow is a Friday, but it's just normal class period for you guys, right? Normal time. So there's that. There's 2 sides. 10 problems. They take a while though. I'll do one right now with you. How about that? Okay? All right, bye TJ.